Welcome back to Josh Does Math. In this video, we're going to be doing some derivatives using the clever rules as opposed to evaluating the derivatives as limits. So here's our three functions right here, and our goal is to find the derivative of each one. So for the first one, we're looking for d 6x to the 9 dx. So the first rule that you can apply right here is the constant multiple rule. It says that you can pull that factor of 6 out front. So that's what we'll do. 6 dx to the 9 dx. Now what rule can we use? Well, you can see that x is raised to some power. It's just plain old x to some power. That looks like we can use the power rule. Power rule says power out front, one smaller on the power. So that's what we'll do. Pull the power out front, so I pulled 9 out front, one smaller on the power. That means that the 9 becomes an 8. And now I just simplify the factors out front to 54 x to the 8th. That's the answer to the first one. Second function down here, we're going to be looking for the derivative of the function 19. d19 dx. So just think about what this is asking. This is asking what is the rate of change of the function that's just 19 all the time with respect to x. Well, it's not changing at all. If I were to graph it, here's the graph of f of x equals 19. There's 19 up there, and it's just a line like that. It never changes. So this is known as the constant rule. If you're taking the derivative of some constant, it's always just 0, because the constant does not change. Hence, it is a constant. Last one down here is going to be very similar to the first one. We're looking for d negative 15x to the 4th dx. So the first rule that we can use is the constant multiple rule. Pulling that negative 15 out front, taking the derivative of the rest of it. And the second rule that we're going to use is the power rule. One smaller, pull the power out front, so I'm pulling 4 out front. One smaller on the power, I'm turning that 4 that's up in the exponent into a 3. And now I just multiply this, I get negative 60 x to the 3rd. That's the answer to the last one. So these are just some practice problems for evaluating the derivatives using the clever little rules instead of going the long way and evaluating the derivative as a difference quotient in the limit. So that's how you do these kinds of problems. Thanks for watching.